Could Mars once have hosted life? For decades, this question has fascinated scientists, explorers, and dreamers. Now, with new discoveries from NASA's Perseverance and Curiosity rovers, and even China's Zhurong rover, we may be closer than ever to answering it. Today, we'll explore the most promising evidence yet of past life on Mars, including strange leopard spot rocks, long carbon chains, and even signs of ancient Martian beaches. This isn't science fiction. These are real discoveries, peer-reviewed, analyzed, and shared by NASA and global space agencies. And by the end of this video, you'll understand why scientists are cautiously excited, but not yet ready to say the words, "We've found life on Mars." Before we dive into discoveries, we need to ask, what counts as evidence for life? Scientists look for what are called biosignatures. These are chemical, mineral, or structural traces that may indicate biological activity. On Earth, things like fossilized microbes, certain minerals, or complex organic molecules often point to life. But here's the challenge. Many of these things can also form without life, through purely geological or chemical processes. So the goal on Mars is not just to find something unusual, but to find patterns that strongly suggest biology rather than chemistry. And that brings us to one of the most exciting discoveries yet, the Chayyava Falls rock. In July 2024, NASA's Perseverance rover drilled into a strange rock in Jezero crater. Scientists nicknamed the rock Chayyava Falls, and the core sample taken from it was called Sapphire Canyon. What made this rock so intriguing? It was covered in pale, leopard-like spots, off-white splotches surrounded by darker material. When Perseverance's instruments analyzed the core, they found minerals like vivianite, an iron phosphate, and gragite, a form of iron sulfide. On Earth, both minerals often appear in watery, low-oxygen environments that microbes love. Even more exciting, the rock also contained organic carbon-bearing mudstones, meaning there were actual carbon-based molecules preserved inside. These were associated with iron, sulfur, and phosphorus, key elements for life. Some scientists describe this as the most promising biosignature yet on Mars. But here's the catch. While these minerals and organics can be formed by microbes, they can also form without them, under the right chemical conditions. That's why NASA is careful. They're not saying, "We found life." They're saying, "We found something that might have been influenced by life." So is this proof? No. But it's one of the strongest clues we've ever had. To understand these discoveries, you have to imagine Mars billions of years ago. Today, it's a cold desert world. But in the distant past, Mars had flowing rivers, vast lakes, and maybe even oceans. Recent rover studies show that water conditions on Mars changed over time. At first, many environments were acidic, harsh, corrosive, and not very friendly to life. Later, conditions shifted to more neutral and alkaline waters, much better for habitability. This matters because if microbes ever lived on Mars, they would have needed those gentler, neutral waters. The fact that Perseverance is finding minerals and organics from this more life-friendly period makes the case even stronger. In 2025, NASA announced another breakthrough, this time from the older Curiosity rover in Gale Crater. Scientists detected the longest carbon chain molecules ever found on Mars. These chains, called alkanes, included molecules with 10, 11, and even 12 carbon atoms. On Earth, similar chains are part of fatty acids, essential ingredients of cell membranes. Now, does this mean Martian cell membranes existed? Not necessarily. These chains could have formed through non-biological chemistry, but the fact they survived in a 7-billion-year-old rock shows that Mars can preserve complex organics for billions of years. And that makes it much more likely that if life once existed, we could still find traces of it today. And it's not just NASA making discoveries. In 2025, China's Zhurong rover provided radar data suggesting ancient sandy beaches in Utopia Planitia. Layers of sediment detected beneath the surface resembled shorelines shaped by waves. This supports the theory that Mars once had massive oceans, covering up to a third of the planet's northern hemisphere. And where there's water, especially stable, long-lasting bodies of water, there's the possibility of life. So let's recap. We have rocks with biosignature-like textures and minerals, We have organic molecules, including long carbon chains. We have strong evidence of ancient lakes, rivers, and oceans. And we know Mars had periods of water chemistry that could have supported microbes. Taken together, this paints a compelling picture. Mars was once habitable. It had the ingredients for life as we know it. But does that mean life actually emerged? That's the million-dollar question. There are still big unknowns. First, almost every biosignature we've found so far could also be explained by non-biological chemistry. Rocks can make organics without life. Water can deposit minerals without microbes. Second, time is the enemy. Mars has been bombarded by radiation for billions of years. Any delicate traces of life could have been destroyed or altered beyond recognition. And third, our rover instruments are powerful but limited. They can't do the same level of testing we can in labs on Earth. To confirm life, we need to bring samples back. That's why NASA and the European Space Agency are planning the Mars Sample Return mission. If successful, it will bring pieces of Jezero crater back to Earth by the 2030s. Here, scientists can use advanced microscopes, isotopic testing, and molecular analysis to determine whether these organics and minerals are the products of life or just chemistry. It will be one of the most important scientific missions of our generation. For the first time, the evidence is stacking up. Water, minerals, organics, and preservation over billions of years. Each discovery alone might not mean much. But together, they form a story that Mars was not always dead, dry, and lifeless. It was once a world with lakes, rivers, and maybe even oceans, a world where life could have started. And if life began on Mars independently, then it means life in the universe might be common. We would no longer be alone. So what do we know? Mars had the right conditions. We've found promising biosignatures, organic molecules, and evidence of ancient water. What we don't know, whether any of it was truly biological. For now, the mystery continues. But with each new discovery, the possibility that Mars once hosted life becomes harder to ignore. The next decade may finally give us the answer to one of humanity's oldest questions. Are we alone? Until then, Mars keeps its secrets, but we're closer than ever to unlocking them. If you liked the video, please like and subscribe.